Good evening, ladies and gentlemen, and welcome to another edition of TBR. I'm George Binns, and this evening we're going to talk a little bit about windmills. And the we is me and Jim Modugno. He's back again.
Absolutely.
Welcome, Jim.
Like a bad penny. Thank you for having me back.
Yeah.
I wanted to talk about basically wind power.
Yeah.
A lot of times we refer to them as windmills or wind turbines.
Yeah.
They're both the same. They're used interchangeably. Sometimes when you're reading articles or looking at research, they kind of blend them together a little bit.
Yeah.
In previous shows we talked about electrification of homes. We talked about the risk and rewards of those type of things. We did an EV vehicle show.
Yeah.
And again, we really focused in on the rewards and the fixes and the really the risk associated with it. And then, one of the things we covered then, and I want to start right from the beginning because I think it's important when we do the wind power deep dive that we understand why we're doing this and what we're looking at.
Yeah.
So when you look at the current power generation that's critical to all our needs today, right, to our needs today, 64% of it comes from fossil fuels. It breaks out very simply into 35% of natural gas generation plants, 28% are oil, and a very small number, 1.5% coal.
And what you're talking about, just the electric power demands.
Yes, this is
Okay, so there's additional demands for transportation, for fuel oil and all that kind of stuff. Yeah.
Yeah, so what we're looking at is just the
just
generation.
the electric power, yeah.
Yeah, the generation of it. 20% of our energy comes from nuclear.
Yeah.
Right? And then you break it down into the renewables, right? And that's 15.5%. And when you break it out, it's hydro power, right? 6.3. Now, some people believe we're totally maxed out on hydro right now. And so nobody thinks we can actually get much more out of what we have based on it takes a certain amount of river and dams would have to be built, et cetera, et cetera.
Well, one of the concerns that they've come across is that if you're not careful where you build the dam, you add additional weight on the earth. And next thing you know, you're getting little shock waves. So it's
interesting.
There's physical limits to how much can the ground hold. And there's some places it doesn't work.
In terms of fault lines and other things that might be in place.
The other fun one is they built the dam at one time in an area with a lot of sandstone, and they could never fill up the lake behind it.
A little porous, isn't it?
Yeah. All the water kept leaking off.
Yeah, so you got the hydro, and then you have the wind, which is approximately 6.5%, and then you go to solar, which is down to like 2.7.
Yeah.
So in terms of solar panels and everything, there's a lot of room that people can put them on their homes. There's a lot of things that could happen in that direction. And when you think about it, this only covers our current demand. Doesn't even take into consideration what our future was. So if we go to strictly free renewables, right? Cut out everything that I talked about in fossil fuels or nuclear, we've got to be able to replace 84% of our current generation, and there's no way that can happen over the next 13 to 15 years, or the Biden plans or whoever the plans are coming from, right? And so when you look at that, we kind of back ourselves in the corner, and so that's kind of like the base of where we're coming from. And so I think exploring all these are good. I don't think we should ignore them. I think it's valid to look at them, and there's some good points and some bad points to this. So I want to jump right into the wind turbines or the windmills. And you think about the windmills. I think the earliest time, I think you and I might have been conversing a little bit, it goes all the way back to the Persians in like 644 AD, where they had windmills that they used. And the purpose of them in those days was basically to pump water to irrigate the lands and so forth. The second part was to turn the milling wheels so they could do the grains and break them down. So that's where we were. Now all of a sudden, it stops. And so the question I always had was, why did they stop using the windmills per se? Although, at its height, there were over 2,000 of them in Europe at one point, up to 1850. The reason it does with Industrial Revolution, and with the Industrial Revolution, what we came up with is we came up with steam engines, and we came up with combustible engines. And the key thing here is both of those items allowed us to generate energy with less manpower.
Yeah.
Right? And that is really, if you think about it, you want to go out there and you want to turn a milling stone with manpower. I mean, that's not. It took a lot of people to do that type of stuff. So it's really efficiency. The other thing that we came about when we moved away from them, all right, at that moment in time is these sources were much more dependable than wind.
Yeah.
Right? So I think that's, one of the key things. So the question we always have to ask ourselves, $64,000 question is windmills the right thing for everybody now? And so when you think about the green initiative, you have to answer it this way. Will wind power, one of the 3 acceptable forms of free energy, be able to power us 24/7 times 365 days a year in a dependable fashion that would be able to keep our economy and our quality of life to remain high?
Well, the basic problem is they're not. And what do you do to store energy for when the wind turbine isn't spinning or the solar cell hasn't got any sunlight?
Right.
And it all depends on some sort of storage mechanism. And one of the favorite storage mechanisms they use, especially in the Tennessee Valley Authority, because the nukes have a similar problem, that you don't want to shut down a nuke or you don't want to have variable power levels. You like to run it flat and steady. So as a result, when you have a peak load, they go to pump power storage, where you pump water up a hill and put it behind the dam. And when you need it, you open up the petcock and turn the turbine.
Almost like
Well, that's fine if you got a high hill available. Excuse me, but not necessarily every area has got this. Where do you store that kind of power in the desert? Not going to happen.
Yeah. And so these are the type of challenges that obviously are out there. And we can talk a little bit about battery power in the future, in storage, in terms of battery storage, which is another whole topic you could actually get into. But when I looked at this again, I said, let's look at the pros that they have on it. And so the narrative is always that wind's free, right?
Yeah.
We can argue that till the cows come home, but it's tagged as a renewable resource, but it's not really a renewable resource. You either use it or you lose it.
Yeah.
Right? So that's not exactly clean. It's a clean energy, and it can be generated any time the wind is blowing. So that's the question mark. Is it really clean? And I think if you just say, I got a windmill and I'm using the wind to generate my energy, yeah, you might think of it as being clean, but is it really clean? And I think that's where I started drilling into it. They claim they use no fossil fuels to run it, but that's not necessarily true, right? So they always have an energy or an electrical line coming in because they always have to keep the windmills up and running, and it really powers their internals in terms of electronics and other things that have to be there. So there's always a connection there, right? So then I looked at this, okay, where are we going to have windmills? And typically we see them in the center part of the country. We see them along the coast because this is where you get a lot more of the wind and so forth. So it isn't good for everybody, and it isn't going to be able to be located. And so then I started looking at it and said, did I miss any of the pros? Because I was having trouble finding a whole lot of them, right? So then I jumped in and said, okay, what do I know about windmills? Well, I had to work under one for, I was probably within 500 feet of it inside a building, but we still had that windmill working behind me, right? Mm-hmm. And the bottom line is it's noisy. You can hear it. You can hear the blades moving through the wind, right? Mm-hmm. Aesthetics, is there something pretty about a windmill? I don't think anybody wants them in the neighborhood, right? I don't think you could put one up in Beverly anywhere that you could actually get the benefit that you need based on the cost. So then I looked at health issues. And there's lots of reported health issues around people who live near and around windmill or wind turbine location farms. And they range from anywhere from, dizziness or chronic pain or blood pressure that's higher. Now these are all being investigated. Are they, but the recommendation is you should probably be about 6,200 feet away from one.
Yeah.
Right? So somebody knows something about something, right? Yeah. So I looked at that and I said, okay, where are you going to locate them? So we talked about the suitability. They need 10 to 15 miles per hour just to keep it turning, right? And to be able to generate. And then if you're running over 45, they automatically have a shutdown if there's too much wind power up there.
Yeah.
They shut them down. So again, you're going to find yourself like in the winter, ice storms, windstorms, hurricanes. They're going to be locked down because you can't let them run. You're going to blow the gears up in the gearbox, right?
Yeah.
Up in the nozzle, right? So,
Well, the other thing too is the blades ice up, and they throw big chunks of ice around too.
yes, they have. And having worked up at Applied Materials, there were at least 3 cars that were in our parking lot that was underneath them that had icicles that went through their roofs, through the windshields, and through their trunks.
Yeah.
Right? So, and it can be dangerous. And during the winter, when there was ice conditions, we had to park a quarter mile away and pick up the shuttle to come to our building.
Yeah.
Right? Because they couldn't take the risk. It was a safety hazard. Right?
Yeah.
So put it up. So there's all kind of things that go with it. But one of the biggest ones I had overlooked initially, but as I researched it, I found that the footprint, you typically need 1.5 acres of land for the footprint for just the tower and the blades rotation and everything. Now, they recommend all the land around it be stripped of trees, so not to interrupt and create additional turbulence around it.
Yeah.
You know? And then I looked at it, okay, what is a wind farm? Where do they locate all this stuff? Well, in upstate New York, they have several wind farms. They have them out in Texas, where we heard about the ice storm, and they had all kind of problems with that. So they do happen, and they have them. So if you think about that 1.5, I asked myself the question, all right, what would it take to power New York City? So I looked into that and said, well, let's do the calculations. They said it's 1.5 on an acre. A typical wind farm is 150 turbines, and they sit on 225 acres. So I did all the math with that based on what the needs were. To power New York City, you need 57,000 acres of land to be able to put your wind farms on. You also need 38,000 turbines to be put up. And that's just for the demand today.
Yeah.
It's not for the demand in the future, right?
Yeah.
And
Well, the other thing too, when you talk about demand, you're assuming they're running 24/7,
they don't.
and they don't. Yeah. So if you're going to have some sort of storage mechanism where you have overcapacity so that you can not only meet your current demand, but you can also fill the storage source, whatever that is, the battery pack or whatever you're using, you're now talking at least 2, maybe 3 times that kind of installation.
I read a report by a gentleman by the name of Ken Gregory, and he was estimating if we went all renewables, what would you need for battery backup,
Okay.
right, for the country? And so based on current usages today. And so what he figured it out is that you'd have to have battery technology that right now doesn't exist, that would have to store that energy for months on end, maybe as much as 6 months worth. And that to be able to bring that system into play, it's $100 trillion of expenses. Now, I don't think anybody is thinking about that. I wasn't thinking anywhere near that. But when you think about it, our GDP is only 22 trillion a year, and this is 100 trillion.
Yeah, it's 10 years.
I don't know where they'd get the money for it.
Yeah.
Right? I mean, they can do their voodoo economics, I guess, but that's definitely
The magic fingers on the keyboard at the Fed.
Would you like to print some more money, and can we have another inflationary period?
Yeah.
So then I looked at it and said, okay, so what really goes on? What are they using up there? And what I found is that these are huge items, right? I remember them being put up, and it took months to prepare the site to do it. And then it took months to actually put the tower into place, and then put what they call the nissel on top, right? And then you hitch on your blade and hub, right, to get it in position. And that takes a lot. And what it takes is that the windmill down in Gloucester came in from Germany. So it came in with its bases first. They had to put them on trailer trucks, then bring them up. Then when they had to bring up the blades, when they came on the next ship, they actually had to close down roads because these blades are 120 to almost 200 feet in length.
Yeah.
Think about putting them on flatbeds at that. Everything's hanging over the edges, and they have to cut down some trees. They have to move, lift some power lines to be able to slide under them. So
There's been some interesting YouTube videos of a trailer with one end of the blade at one end, bunch of wheels at the other end. They try to negotiate this thing around through some town or make a right-hand turn from one highway to the other. And it is spectacular. It's a major undertaking, yeah.
It was fascinating to watch. It was kind of scary also to watch because it's just, then when they go to lift them up into place, you're talking about each one of those blades, 27,000 pounds is that what they need to lift. And each blade costs anywhere from $250,000 to $300,000 a blade. So you're talking about, 750,000 of the smaller ones to the larger ones. You'd be close to $900,000 for it. A wind tower with the turbine already in place is about a $4 million bill.
Yeah.
Right? $4 million bill. And so, some of the things they talk about, it kills birds, I kind of said, okay, I put it on my list, but I didn't, it's going to happen. There's no question about it. But one of the things I really was focusing on is 80 gallons of oil are used to lubricate it up in there in the gear shaft, which has to be changed out once every year, at least. And so you think about how much is used in each turbine and everything else, and think about all the expenses in terms of diesel for all the trucks that move stuff to the plant, and for those huge cranes that have to lift it 300 feet in the air, right?
Yeah.
They're using a ton of stuff over a week's period of time. So it's not exactly what we call clean. They can't get away from the oil. They can't get away from electrical source coming in general to power it initially to keep the backgrounds working. So you got large trucks, you got cranes, you got freight trains in some cases in some parts of the country, to move some of these things, heading out that direction. You got ships that are bringing in it, and a lot of that product that we used for the turbines come out of Europe, typically Germany.
Yeah.
Right? So.
Well, and the blades themselves are all fiberglass, which is, again, a petroleum product. And the other thing that I think a lot of people don't recognize is this gearbox that we just casually talk about. It's got a blade that's spinning at maybe 20 times a minute.
Yeah.
And when you get to the other end of the shaft where you're spinning a generator, you're up around 3,000 RPM or better.
It's flying.
So it's really moving because you're making 60 AC, 60 cycles per second AC out of this stuff.
Yep.
And, that is a big piece of machinery up there. And it's probably as big as the generator or bigger.
Yeah, and that's one of the things you're talking about is the use of the blades and so forth. And we talked about the composite. It's really the article you sent me with the composite about the landfill. They were putting all the damaged blades into landfills up in, I believe it was Montana.
Yeah.
So they just clear the earth, they lay them all in, and then they bury them.
Yeah.
Right. They were the problem is they didn't know really how to recycle them, and they're still struggling with recycling.
Yeah.
How to do those blades because they're really a very hard composite that they've generated and make. So there's a lot that really goes into it. And when you think about it, right, there's 200 to 230 metric tons of steel to make a wind turbine. Now, you and I both know a little bit about how steel's made, right? And you're not going to make steel with wind power.
No.
You're not going to do it with solar power. You've got to be able to generate a ton of energy and so forth. And then, oh, by the way, you're using, for each metric ton, you use 0.77 metric tons of coal to be able to generate the heat and everything and the whole process of creating what they need for the steel.
To run a blast furnace, you're going to use a lot of energy.
A ton of energy.
Yeah.
A ton. And what they're talking about is that there's when you talk about 165.6 metric tons of coal to produce each windmill, that's what you'd end up having, right? And then you think about it, it's 1 billion tons a year is for just the windmill industry alone, generating the energy.
We're trying to shut down the cold.
Yeah, I mean, they're trying to shut it down, and natural gas can help in some aspects, but it's basically you need coal, right, to be able to do this process. And
Theoretically, you can do the whole thing with electricity,
yep,
but you can't get electricity without burning some fuel.
exactly. That's exactly what my conclusion was.
Yeah.
Right, you just get right to it. There's not a whole lot you can do with a lot of that stuff. And you think about a broken gearbox. If you got a gearbox that goes down, and when I was down at Applied Materials and that windmill went down, it needed a new box. It needed a new gearbox, new transmission. That meant we had to wait for it. And that was down almost a whole year
Yeah.
because it had to be shipped to us. Then you had to get, oh, by the way, you had to get the crew in again,
Oh, yeah.
who bring in their heavy cranes and everything else to be able to now go up, pull the old one out, put the new one back in, put the hub and blades back on again, right?
Yeah.
Because you got to pull it off the shaft.
You have to take the whole thing apart.
Yeah, you
to get
do.
to the gearbox.
Yep.
It's one thing to change out the transmission in your car. You just go to AutoZone and get a new transmission, but doing that up in the air, you're up 300-400 feet in the air.
Yeah, you're up there around 290, 300. You're right.
Yeah.
And that's a lot. That's a lot to be able to lift up and on.
Yeah.
And so the maintenance on it is, we're talking about something on land.
Yeah.
And of course, the industry really would love to do more wind farms out in the ocean, right?
Mm-hmm.
And the cost of those actually go up because of the fact that putting bigger ones out there, so they cost more.
Oh, yeah.
You have to bring transmission lines in. You're bringing them under the, you're putting them on the bed of the sea to bring them up. You got to have a transmission station at the beginning. You have to have a hub, and then you have to be able to maintain them.
Yeah.
And what do you do when you get the, especially some parts of like New England, winter storms, hurricanes, or tropical storms? Maintenance on them. Sometimes they go down. Sometimes they're going to be down for a long period of time while they wait for a product to be able to go out and find the right weather to be able to go up. And if you think you're going to swing something that weighs, maybe about 8 tons up in the air, you get some work cut out for you.
Yeah.
Right. So.
And what you're pointing out is that each one of these turbines that goes up is unique. And there is no standard set of supplies of when something goes down, you just go to the shelf and pick up another one. It probably has to be re-engineered, redesigned. And where did we leave those drawings, for the last one, and to make another one?
Yeah, or and in some cases, people, I've read articles where they put a windmill in, the people they bought it from basically went out of business, or they had a major failure and they just couldn't handle it, and they had to go bankrupt. So
Yeah.
who gets stuck with that bill? The person who gets stuck with that bill is if you're a private company, you put one up, you're stuck with it, but
Yeah.
you pass it on to somebody, right?
Yeah, it shows up at the bottom line someplace.
Absolutely. So if it's public entity or such as the wind farms are, they're just passing that cost down to the consumer on electricity. My whole research on it is came down to, listen, it's expensive to do that. When you put a wind farm up and you putting one up, you may not be buying the land, but you're renting that land every single year to this bill. You need insurance on these things because they're extremely expensive and so forth. So that's a fee for you, and then you have the maintenance and the repairs and operating costs that go with it. So and just a minimum amount of operating expense that you're going to plan for is somewhere around $50,000 per windmill, and that's just maintenance.
Well, when the wind turbine farm went up off of Block Island,
Yeah.
they were touting that thing because Block Island used to run on diesel power generators, which noisy and messy, but anyway. And they put up this farm, and it was supposed to be able to handle 2,000 homes. It's a good-sized farm. And they went through the calculations, and the cost of installing it was $150,000 per home.
How cost effective is that?
Yes, so it sounds like a good idea. You're getting essentially free energy. The wind is free.
Yep.
But the cost of capturing it and converting it to something useful,
Yep.
that has got to be very expensive. And one of the other issues that keeps coming up is Right now, I think the wind turbine farm is down because the cable from the farm to the land station is out of commission. And I haven't been able to find out whether it's up and running yet again, but it's been down for a year or two because they tried to bury the cable, and for some reason or other, it got unburied.
Yep.
So they had that's sort of a problem.
Yeah, I mean, there's every potential solution, there's always going to be issues that need to be resolved, right? And most of the time, people can kind of work them through. The one thing that I continue to keep learning from these things is the fact that when you look at what they're doing and what they're thinking, they're selling it as free, right? It's free energy type of thing, and it's good for the environment. They're actually using more carbon footprint for each tower than they're actually generating.
Yeah, it's not a net saving.
It's not.
And I think this is part of the major problem with a lot of this so-called green stuff is the end product looks good.
Mm-hmm.
But to get there, it's very expensive in terms of just the plain cash you have to lay out to make it happen,
True.
as well as its impact on the environment they're so worried about.
Exactly, and I think we all share the fact that we want clean air, we want clean earth, we want clean, water. I mean, and we all want to strive for that. The one thing that I constantly keep coming back at every time I have a show with you, George, is the fact that there's no plan. It's helter-skelter out there. Right?
Yeah.
And what we need is, every business does it, has a business continuity plan. They figure out what it takes to run the business. They figure out if they want to make changes. What are the risks if this happens or that happens? They need to know those things, right? And so they need to have a plan. They don't seem to have a plan, and I think that's the problem.
Well, one of the things that you haven't discussed yet, and these turbines have a finite life.
They do.
20 years or something like that.
Yep.
If you build a nuclear power plant, it has a finite life. Before you build a nuclear power plant, you have to put money in the escrow account for decommissioning.
Yep.
They don't have a decommissioning account for the wind turbines. So when this wind turbine dies, everybody walks away and there's a Pontius Pilate.
Yeah, that's exactly. It's high expense. These are high expensive alternatives. So I kind of look at this whole thing. We'll probably coming to an end here, I think, shortly. I'd just leave it with a quote from Ralph Waldo Emerson.
Yeah.
Not that I'm a philosopher at all. Is adopt the pace of nature, right? And her nature is to be patient.
Yeah. And ladies and gentlemen, thank you very much for watching. And this story about the Green New Deal is going to be ongoing, and we'll have more to say about it. And my closing line is Europe is now considering nuclear power and natural gas as green. Stay tuned, it's going to get interesting. Thanks for watching, and if you have a different comment, my email address shows up after the credits. Send me an email and we can make room for you at the table. Thanks again, we'll talk to you later.